Imagine you're playing cricket with your friends. Now let's analyze the situation using geometry. Let's say that your pitch is along the x-axis and the ball is coming from this direction. This is you, your bat, and the wicket. And there are other players. So if the wicket is behind you and the bowler is in front, you have people on your left and right as well. So let's have one more axis. This is your y-axis. And we have a lot of other players on the field. Let's mark them. We have this, and the wicket keeper. All right. Now let's mark the coordinates. Let's say your wicket is at the origin. That's 0, 0. This person is 15 units away. So that's 15, 0. Wicket keeper is 1 unit behind. That's -1, 0. And similarly, you can mark coordinates for every single one of them. We have these, and this coordinate. All right. Now the question for you is, and there is no right or wrong answer, you can give this one a guess. What are the coordinates of the top of the wicket? Not the wicket or the bottom of the wicket. What are the coordinates for the top of the wicket? Pause the video, think about it. We'll come back to this towards the end of the video. Now something that you might be thinking about is dimensions. Do we live in a 2D world where we only need 2 coordinates for each point? Or we live in a 3D world where we need 3 coordinates? To the best of my knowledge, we do live in the 3D world. We might use 2D maps, but we live in the 3D world. And what do we really mean by these words, 2D, 3D, dimensions? Let's break that down. Let's start from the very beginning. Let's start with something that's 0 dimensional. Now 0 dimensional means that you have no dimensions. Then there are things that are 1 dimensional, 2 dimensional, 3 dimensional, and beyond, but we'll stop at 3 for now. So can you think of an example that's 0 dimensional? A point is 0 dimensional. What about 1D? Well, a line is 1 dimensional. 2D, a piece of paper can be 2 dimensional. And there are many examples for 3D. You can have a cube, your sweater, a rabbit, or a tree. All of these things, all of these real things that we see in the real world are 3-dimensional. But these are examples. We want to understand what we really mean by the word dimension. Well, loosely speaking, in math, dimensions give you the degrees of freedom. This gives you the number of perpendicular directions in which you can freely move. So when we talk about 1D objects, for example, this line, we can only move along one direction. We can either move forward or backward, but this is the only direction that we have. When you're in 2D, you have 2 directions. This and this, x-axis and y-axis. But when you're in 3D, you have 3 directions, and for that we need 3 axes, x, y, and z. You can move forward and backward, you can move left and right, and you can move top and bottom. So you have 3 perpendicular directions to play with. This is what makes things 3-dimensional. When the point is your entire world, there is nowhere to move. When you are on a line, at least you have 1 direction to move. A plane gives you 2 directions and space gives you 3 dimensions. For a line, we need 1 axis, for example, x-axis. For a plane, we need 2, x and y. And for space, we need 3 axes, x, y, and z. Let's see this in action. When we only have a point to work with, there is nowhere for us to move. When we have a line, let's say we have our x-axis, we give us 1 dimension to move. We can now move along the x-axis. When we add one more line perpendicular to this, let's call this the y-axis. Now we can also move along the y-axis. So we have unlocked one more degree of freedom. In this case, we have 2 degrees of freedom. One along the x-axis and the other one along the y-axis. And together, they make up the entire plane. If we add one more dimension, if we add the z-axis, we now have 3 dimensions to work with. We can move along the x-axis, we can move along the y-axis, and we can move along the z-axis. We can go above this plane and below this plane. And now we have entered our 3-dimensional space. All right, let's talk about coordinates. When we're in 2D, we only need 2 coordinates, x and y. So they can be written as x and y. But when we're in 3D, we need 3 coordinates, x, y, and z. These coordinates tell us how much we have moved along these axes. For example, if we have 2 comma 6, let's mark 2 comma 6. We move 2 units along the x-axis and 6 units along the y-axis. So this is 2 comma 6. But if we have 2 comma 6 comma 4, this means we've moved along x-axis, y-axis and z-axis. So 2 comma 6 comma 4 is above this plane. This is where 2 comma 6 comma 4 lies. So this point is in 3D space. This is 2 comma 6 comma 4. All right. Now these two axes, the x and the y axis, divide this plane into 4 parts. We call them quadrants. So we have these 4 quadrants. Let's mark the axis, x and y. Now they divide this plane into 4 parts. This is the first quadrant. This is the second quadrant, the third quadrant, and the fourth quadrant. The top right, where both x and y coordinates are positive, that's the first one. Here we have x negative, here we have both negative, and here we have x positive and y negative. So these are our 4 quadrants. Something very similar happens in the 3D world as well. Think about it. If you have one more axis, in how many parts will these 3 axes divide the entire space? Pause the video, think about it. All right, let's do this together. This x-axis in 3D will slice this space like this. Y-axis will do something like this. And z-axis will do something like this. So how many parts do we have? Well, in 2D we had carpets, in 3D we have rooms. Think of this as your ground floor. You have 4 rooms on the ground floor. And then this is our basement. We have 4 more rooms in our basement as well. So together we have 4 plus 4, 8 rooms, and we call them octants. Quad stands for 4 and oct stands for 8. So 4 quadrants in 2D, 8 octants in 3D. Let's see them in action. We have the first octant. This is our first octant where all 3 things are positive, x, y, and z. Then we have the second octant, third octant, and fourth octant. These 4 rooms are on the ground floor. And then we have our basement, 4 more rooms in the basement. We have our 5th octant, 6th octant, 7th octant, and finally our 8th octant. So these are our 8 rooms, 4 above and 4 below the XY plane. These are called octants. All right. So we have 4 parts in 2 dimensions and 8 parts in 3 dimensions. And there is a pattern here. For 2 dimensions, we have 4. For 1 dimension, we have 2 parts. For any line, we can have a positive side and a negative side. Think about the real number line. And even for the point, we have 1 part. This entire thing is just 1 single part. So every time we're adding a dimension, we're multiplying the number of parts by a factor of 2. And there's a proper naming convention for these quadrants and octants. In 2D, the top right is always the first quadrant. Similarly, in 3D, this octant where all 3 coordinates are positive, x, y, and z, that's the first octant. Let's visualize this. When we have a point in 2D, if we have positive x and positive y, we're in the first quadrant. When we have x negative, we're in the second quadrant. When we have y negative as well, we're in the third quadrant. And then when we have x positive and y negative, we're in the fourth quadrant. Similarly, when we move in 3D, let's move in 3D, we have x positive, y positive, and z positive. We go up along the z-axis. This is our first octant. Now let's stay up, let's stay on the ground floor. Let's start moving. When we have our x negative, this room is our second octant. When we have both x and y negative but z positive, this is our third room or third octant. Then we move to this one. This is x positive, y negative, and z positive. This is our fourth room. So we're moving in this circle anti-clockwise. Let's do this again. This is our first octant, second octant, third octant, and fourth octant. We'll go to the basement. Let's come down. This is our fifth octant. This one's fifth. Fifth is just below the first one. Then you have sixth. Then you have seventh. And finally you have eighth. So 4 above and 4 below. 1, 2, 3, 4, and then in the basement 5, 6, 7, and 8. These are our 8 octants. In 2D, the quadrants were above and below the x-axis. In 3D, the octants are above and below the xy plane. This plane is called the xy plane because it has x and y axis. Similarly, this is zy plane and this is xz plane. Alright, now let's practice some problems. Here's the first one. A point is on the x-axis, find its y coordinate and z coordinate. Think about it. Okay, if the point is on the x-axis, this means it's not moving along the y or z axis. So if it's on the x-axis, there is no movement along the y-axis or along the z-axis. This means that the coordinates will look something like this: x, 0, 0, 2, 0, 0, 5, 0, 0, minus 3, 0, 0. These two will stay 0 because we have no movement along these two coordinates. Here's the next one. A point is on the YZ plane. What is its x coordinate? Think about it. Okay, so this is our YZ plane. Imagine a point on this plane. Let's move along y-axis and then let's move along the z-axis, and we are on the YZ plane. Any point on this plane will have no coordinate along the x-axis. There is no movement along the x-axis. We only have movement along y and z. This means the coordinate will look something like this: 0, y, z, which means the x coordinate is 0. Alright, let's solve a few more. Name the octants in which the following points lie. Now I'm going to list down 5 points: 1, 2, 3, 4, minus 2, minus 3, 4, 2, minus 5, minus 4, 2, minus 5, and minus 4, minus 2, minus 5. Pause the video, think about it. In fact, close your eyes when you're imagining, when you're visualizing, where are these points lying? In which octant are these points lying? Alright, let's do this together. 1, 2, 3. So we're moving 1 unit along the x-axis. Then we have 2 units along the y-axis. Okay. And then 3 units along the z-axis. So 1, 2, 3 is here. 1, 2, and 3. All 3 points are positive. This means that this is in the first octant. Let's look at the next one. 4, minus 2, minus 3. So we move 4 units along x-axis and then minus 2 along y-axis. So we move back and then minus 3, which means we go to the basement. So minus 3. Which octant? 1, 2, 3, 4, 5, 6, 7, and 8. This is the 8th octant. All right. Any point which has coordinates with these signs, positive, negative, negative, will be in the 8th octant. Let's mark the signs for the remaining 3. We have positive, positive, negative, negative, positive, negative, 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 negative. Now let's think about these signs. Which octants do these signs lie? This one's in the first octant, this one's in the 8th one,